Okay, so thank you. Good morning. Welcome to our webinar. Today is Unlocking Insight Strategy for Analyzing Non-Normal Data. So I'm Nur Salawati. I'm the Technical Support Specialist at Visit System. Visit System are independent local presentation for Minitech in Malaysia, Singapore and Batam, Indonesia. So before we get started, we have a few housekeeping notes before we begin. We have a Q&A session after the presentation. So please submit any question you have and we will try do our best to answer them. If have a time, if no, I will answer afterwards by the email. So we recommend viewing this webinar on your laptop or PC for the best result. So please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. We record this webinar and upload to our website www.visit.com and our YouTube channel Minitech Malaysia and Singapore. So there's no problem if you miss anything or want to review afterwards. Minitech currently is more than 50 years in the market. So we have others product. We have the Minitech Connect is for those are looking for dashboard or integration with your database. So Minitech Connect it will be fit for you. And then we have our flagship product for today webinar is a Minitech statistical software. And then we have also, we call it the SPM or Suffolk Predictive Modeler. So some of these algorithm inside the SPM available now in the Minitech statistical software. And then we also have the Minitech model ops. When you have your models, you want to apply them or you want to see the prediction side. So Minitech model ops, it will be good for that. And then we also have the Minitech workspace. Minitech workspace is something like you have a we have a template inside the Minitech workspace, and then we have something you do the project. Okay, you have a lot of tools inside the one project. So we have the roadmap in the Minitech workspace. And then, of course, you want to share your project with the management side, your management. You want to see the progress of your project itself. So you looking for that, you need go for the Minitech Engage. With there, we have a we have the dashboard to see or to share your current project or progress your project. And then also we have the education hub, where is a education or training online consists of a few models, something like design of experiment, statistical quality control, and so on. And then of course, for those want to see the real time, okay, for the SPC part, we have the real time SPC when your process is not good. So you have a lot alert from your or notification for the flow to your person in charge, let's say for engineer to handle it for. So we can use the real-time SPC. So we have a lot of the product device in the Minitech statistical beside the Minitech statistical software. I think most of us always see the Minitech, only Minitech statistical software, but now we have a lot of type of the product. Okay, so for those I want to interest to others products, so feel free to contact us. So this one is some of the available tools inside the Minitech statistical software. So I think most of you are already familiar with the something like quality. Those is measurement system analysis. We have the control chart, capability analysis. We have the acceptance sampling. We have the tolerance interval. I think a lot of this information are available now in our website or in our YouTube channel. So for those are looking for that, so you can go for our YouTube channel to see on the MSA or control chart or capability analysis. Okay, so we also have the for reliability engineering. Okay, we get the new tools, we call it the cog regression inside the reliability engineering. We also have something like product development. For those R&D, always do the something research or something experimental. Okay, so we have the design of experiment inside the Minitab statistical software. So we start with the create, from the create design itself. Okay, your combination of your treatment. Okay, so you have a lot of design. We have the screening design, full factorial design, fractional factorial design, or you have something like quadratic. So we go for the response surface. And then, of course, we also have something like business analytic. Okay, for those are related with the machine learning or something that one. So we have the kind of the models now available, starting with the Minitab 19. I think we call it the classification and regression tree. Instead of we also already have the regression. And then for those are looking for regression, I think we a lot of have a new good thing in the regression now in Minitab statistical software. So we also have the time series analytic. So we have the ARIMA models, we have the winter and so on for this. And of course, we also have something like, we have a concept of the tools. And then, of course, that one is a sum of the daily job you need to do. For those are related with the process validation. So all these are available in Minitab statistical software. And here is our customer, but no worries. This customer is coming from the various sector, include the manufacturing, academician, services, and so on. So, of course, this software is a fit for, I think, fit for all, as long as your company is a data-driven company, or will look it to do some decision based on the number or based on the data analysis. But okay, so today's agenda, we go for the something always our customer, or always we receive the question like, what should I do when my data is not normal? Okay, for those manufacturer, I think they must be look on the normal before they proceed to the others tools or other data analysis. Okay, so today we focus on that. So we try why do we need have the normal distribution, and then of course how to assess the normality. Is it your data is a normal or non-normal? We have a few types or method to assess the normality. And after that, after we know our data is not normal, so before we go for something like capability analysis, so what we need to do. Okay, so today we have a list of the several strategy to handle for the normal data set. But of course, I think most of us say that, okay, if let's say my data is not normal, so we go for the non-parametric test. Okay, so but not all the user or the researcher or the practitioner, we use that kind of the method. We have an alternative way, something like maybe you can transform your data set before you go further for data analysis. So no worries, in maybe in 1 hour, we can cover all these things. But before I proceed with this one, so can some of you share your current practices when you face this kind of the with kind of the issue? So when your data set is not normal, what you do right now? Okay, so if let's say you want to share with us, so you can drop your sharing in the chat box. Or maybe you can email us after this. Okay, so I think we have a response on this one. So thanks for those Okay, good one. Okay, so thanks for our response. For those I want to share with us, so you can feel free to email to us. Okay, what the current situation or current practices you do for handling data is not normal. Okay. Okay, so that one is the when we see the or we need have the normal. So your property of the normal is something like you need to have the bell shape. Okay, so you can form the bell shape, and then of course you must symmetrical. So symmetrical something like you get the one piece of the paper, and then after that you fold into the two. Okay, and then you have the same portion, so we can consider that there is a symmetrical. So in term mathematical, maybe when you say that symmetrical, your mean and your median are equal in the center line. So we can be visualization based on the you have your own or same proportion, and then in the mathematical you can transform them. You have a mean and your median in equal side. Okay, or in the center of the line. And of course, if let's say you go for the continuous or Six Sigma, something like one, after you know your data set is a normal distribution, maybe it will help you in terms to the simple prediction. Okay, so for example, for the 1 sigma here, okay, 1 sigma, 2 sigma, 3 sigma. So in within 1 sigma, okay, so you can see that about 60% of the observation fall within the 1 sigma here. If let's say you have a 90%, 95% for the 2 sigma here. Okay, and then of course you want to, if let's say you have a 3 sigma here, it's about the 99.7% observation within the 3 sigma here. So for this case, it will help you the first time you want to do the data analysis. Okay, so it gives you some information. So why we need have the normal distribution. Okay, so this one is a few method of assessing normality. So the first, maybe you can use the graphical. Let's say you want to see, we go back to the basic one, histogram, or maybe you want use probability plot or QQ plot or PP plot we call, or you want have something like analytical, or we call it that one is a normality test. So during to the histogram, we look on the, is a bell-shaped curve? Is it can form the bell-shaped curve or fixed line when you use the histogram or when you create the histogram? Or maybe in the PP plot, you look on the straight line, okay, within the confidence interval between two lines. So we go after this one by one for the PP plot and then normality test. Okay, so we go for the histogram first. Just this one is just maybe it will be just recall back or refresh back. Okay, so the histogram is a divided sample value into many interval and represent the frequency of the data value in each interval with a bar. So basically in the histogram, we assume the shape and the spread of your data. And then of course, in order to get the best result from the histogram, to see the fit or not fit the data, maybe it will be considered more than 20 is a better to represent the distribution. So maybe if let's say you have a less than 20, okay, so you see the distribution is not so good. Okay, maybe you have others alternative to see that. Let's say you go for the normality test, something that one. So in order to see the normal or not normal, so it will not only based only one tools. Maybe you have a multiple tools uh, to assess the normality. So by in a histogram, at least you need have 20 or more than 20, it will be the good to in order to see the distribution of your data set. Okay, So for example, here we have one case study here. Okay, so a quality engineer wants to compare the piston from two supplier. Okay, maybe you have a three supplier. Okay, the engineer measure the length of the random sample of 100 piston from the each of the supplier. So the engineer create the histogram with the fit and the group to compare the distribution of the sample data set. So I think I will go for the Minitab side. Okay. Okay, so for this Minitab, so I focus on this piston length. Okay, so in order to see only the data set, you just go for this data set. If you want to see the both, okay, output in the data set, so you get this icon, or maybe you want to focus on the output only. Okay, I will go back to this one. So for this case, the quality engineer collect the length of the piston, and then the supplier, they have a two supplier, supplier A and supplier B. Okay, so we have many ways to get a histogram in the Minitab statistical software. So for today, I think I will use the go to the graph builder. Easy for you to see on this one. So your length, okay, so I just put it back to this one. For in order to using the graph builder, you just go drag on this part. Okay, so your continuous variables mean to say that it's a numeric. Let's say your data set something supplier. So we not go back to this one. They will go back to this. Okay, since supplier is the T here is a text data set. So one thing, good thing for this case. And then of course, they want to see on the length without supplier A or supplier B. Now we want to see the with the supplier A and supplier B. So you go for the group variables here. So we see on this part, the blue color here is a supplier A. The pink, let's say the red color here will be the supplier B. And then of course you certify with this one, just click on this part. So you will get on this, or maybe you want to add the normal distribute. Okay, so you go for this, okay, for this icon to customize it. Okay, go for the graph option. So we see on the fit here. So you just put the fit. Okay, so we get the fit on this part. You will see on this part. The first step, maybe you will use the go for the graph builder, or maybe you can go for the traditional way we will always use for the graph, go for the histogram. Okay, go for the graph, go for histogram. So you won't see the fit with the group. Okay, so you click OK. So you will get the length here is a categorical, is your supplier. Then you click OK. So you will get the another histogram. It will be the same, but just only different way to get the histogram. Okay, so we have to wait whether you're using the graph builder or you're using the graph. Okay, so we see that the one is the good one is the supplier A. Okay, so I think we use this part, easy to see it. So without for this, okay, you will see on this A, supplier A will be more, it's a bit good. Okay, for the normal distribute, the center line, the skewness, the center is a good, or you want to look on the B only. So without this one. So that one is the spread of your data is a bigger rather than the supplier A. Okay. So supplier B is a supplier A. You will see the standard deviation it will be the smaller rather than supplier B. Okay, rather than supplier B. So we see the spread of the data is a bit more this one. So in order to this one, maybe, okay, you want to check or your data set is coming from two population. Okay, supplier A and supplier B. Okay. So we go back to this part. Okay, so the next we want to assess the normality, we go for the probability plot. So for the probability plot, actually is a they will display each value versus the percentage of value in the sample that are less than or equal to it. Okay, so that one is the Y is a transform. So the fitted distribution form a straight line. So for this case, just visualization here. Okay, so if let's say your data is a normal, so you can form the fat pencil test here, the straight line here. But if let's say your data set is not normal, so you will have a see the curve here, we have this S or maybe more than this part you will see when your data set is the non-normal data set. So in this part, if all the data points on the plot data are probability is a normal inside on this part. Okay, if a point are fair enough from the fitted line, and then if visible beyond the edge of the fat pencil, the data is probably non-normal distribution. Okay, so for this case, I think you can see by your through your eyes, okay, whether it's a straight line uh, or a curve or something that one. Maybe it will be difficult for those first timer. Okay, but for those are already normally use this one, you see, okay, this one is a normal, this one is not normal. So you can see the variability, the standard deviation also you can see, is a normal or non-normal distribution. But that one is available under the graph also for the probability plot. So for this case study, a scientist of a company that manufacture processed food wants to assess the percentage. So the advisor's percentage is about 50%. Okay, so the scientists measure the percentage of the fat in 20 random sample and create the probability plot to check for normality and to evaluate the distribution. So for this one, I go back to the mini tab. I'll use the fat content data set. So they have provide 20 sample and then they collect the percent fat. Okay. So how to get it? You can go for the graph, you can go for the probability plot. Okay. So it was simple since only one. Okay, you go for the simple, click OK. So you will get the fat percent fat and then you click OK. So you will get the probability plot. So same, so you also, PP plot also available in the graph builder. Okay, so you will get to the graph builder. So you go for the probability plot. So for this case, it's a percent. So you just put in it and then you create on this one. So we have a two way, whether you want to use the graph or graph builder, or maybe the same. Okay, so for this case, maybe you want to add or something that one, so you can add this part. Okay, so based on this, you have this one. So seems like a curve here, or it will be the straight line. So in order to see that this dot must be the straight line, play with this straight line. So we consider this data set, it will be normal distribute. Okay. So next, assessing about the normality test. So use the normal test to determine whether the data follow a normal distribution. So in Minitab, by the default, they use the Anderson-Darling test, but we have a others option is Arrayan Joyner, and then we have Komograph Simonov. For the Anderson test and the Komograph, we use the empirical distribution, but the Arrayan Join RJ is using the correlation test to that this one. So that one just only highlighted here. By the default, we use the Anderson-Darling. So might be trigger what is the best. Okay, it will be based on your data set. Okay, it will be based on data set. Which one is the best? It will be based on your data set, or you must know is it how you collect your data set in order to know which one is the best for your normality test. Okay, but of course, a lot of researcher outside there, we use the AED, Anderson-Darling for this case. Okay, so we try with this one, the same case study just now. Okay, the same case study just now for this fat content. Okay, we use the same. How to get it, the normality test in the Minitab? Go to stat, go to basic statistics. and then you will see normality test. You see the normality test. So of course, we want to see the percent fat. And then of course, I just mentioned that just now is Addison Darling. It will be the default setting. But if let's say you want to see the RJ or you want to see the chronograph, you just click on this. So I just proceed with the default by the default first, Addison Darling, and then you click OK. So you will get on this part. Okay. So I will go to stat basic statistic normality test. So maybe I go for the RJ. So and then click OK. So you will see on the RJ. So I will go back to this part. I want to see the chronograph Simonov and then click OK. So for the spike. So we have this thing, the split here, to the split here. Then the spike. Okay, you will see on this one is AD, Addison, Darling, and then RJ, and then the gas. So all this one, based on the p-value more than 0.05, we consider that one is the normal distribute. Okay, of course, there will be value, it will be different because they have different method to get this AD value and RJ value and KS value. It will be different. So we have a in order to check it, maybe you can go for the histogram, or maybe you can go for the probability plot, or maybe you can go for the normality test based on your preference. Okay. But if let's say your data set is more than the 20 or 30, it's a bigger data set, look on the histogram. But if let's say your data set is smaller than 200 or 400, something like one, we go for the normality test. So it will depends on your preference. Okay. So we go for this. Right? So of course, we need to have the hypothesis testing. So you need to go for this. This one is how to do the analysis or how to do the reporting. So you start with the hypothesis testing. Okay, your data follow a normal distribution. Your alternative, it will be data do not follow a normal distribution. That one is the how step to do this part. Okay. And then this one is the sum of indicator for the non-normal. Okay, so the basic one, your data set is not centered. And then, of course, you can be the right skewed or the left skewed. Okay, so you can see your courtesy or skewness value. And then, of course, I think a lot of the manufacturing data set, it will be non-normal is in this one is have a multi-model data set. So multi-model data set, it will reflect that to your population and your sample. You must know about your population. Maybe you take it sample is not go for your representative your population. So it's something like that one. So you need to back to how you collect your data set. Maybe to incorrect this part for multi-model data set, or maybe you need to spread. Okay, for example, you have the supplier A, supplier B. So once you collect all this one, your data set, it will be not normal. But if let's say you separate into the supplier A and the supplier B, the data will be the normal distribute. Maybe that one is how you assign your sample based on your population. So of course you need to know about your population before you take your sample. And then another thing part for the non-normal maybe is outliers. Okay, so many ways to check it, the outliers, maybe based on the histogram, maybe based on the post plot, maybe based on the your maximum and minimum value, your range, your interquartile. So you have a lot of outliers to check the outliers. So one of these criteria, maybe your data set will be non-normal data set. So if let's say you have a skew of your data set, maybe you need to go for the reduce your variability. Okay, so multi-model data set is you have a peak, okay, two peak here. You have a two peak here. So maybe you need to go back to your sampling or your population. And then of course outliers, maybe you can remove the outliers, okay, and then take it the new one. Or maybe for the outliers, something like is a timing. Okay, so your block or something like shape by the shape or something for the outliers. Okay, so we have this one is some criteria how you can look for the non-normality. Okay, so that one is how we will analyze the normality. So we have a several technique to analyze the non-normal data set. So the first part go for the non-parametric. But for those are uh, not have knowledge about the data analysis, about the statistical. So maybe what is the non-parametric? So something like have figure something. For the non-parametric, actually they not look on the mean, not look on the standard deviation. Maybe they have another parameter to insight or to recognize. Okay, for the non-parametric, basically it's the length. Okay, it's something other parameter it consider for non-parametric. Or maybe you can go for the alternative distribution. So maybe not it's a normal, you can go for the variable, you can go for the log normal distribution. And then for your information, in Minitab, we have 40 type of the distribution, alternative distribution. And then of course, you can go for the transformation. In the transformation, we has a lot of type to do the transformation. In Minitab, we have a maybe if manually you can use the calculator, okay, and then use for the transformation you can use the Boxcorp transformation, or maybe you can go for the Johnson transformation. So which one is the best? Okay, so of course it will depends on your data set. Okay, so for this data set maybe Johnson it will be good, for this data set it will good for the Boxcorp transformation. Okay, it will depends on your data set. So we go for the first one, it's a non-parametric. Okay, for those are first time uh, uh, see the non-parametric. Non-parametric is the hypothesis test that not require the population distribution to be characteristic by the certain parameter. So we assume that the parents distribution of the sample is unspecified, and then we are often interested in making inference about the center of the distribution. So maybe non-parametric are useful when the normality assumption does not hold and your sample size is small. Okay, the keyword here, when your sample size is small, and then you check the histogram is not normal, based on the PPP plot it's not normal, based on the ID doesn't it's not normal. So maybe your alternative, it will go for the non-parametric. Okay, but for those are not good or not see best using the parametric, maybe they need to add the sample size in order to get the normality size. Okay, so for this case, we have in Minitab, we go for the stat non-parametric. So that one is alternative. For those are with the, you, for example, you use the one sample t-test for the normal distribution. Okay, your data is normal, so you look on the sample. So to replace that one, you go for the non-metric, you have the sign test, we have the sample will cause a test, and then if for those are two tests, we use the Mann-Whitney test. Okay, and then for those I'll always use the parametric. Okay, one way ANOVA, maybe you can use the Kruskal-Wallis or Moore's median test. For those are using the two-way randomization block ANOVA, maybe you can use the Friedman test. So as long as you can solve your problem, okay, so you already do the transformation, you already do the transformation Boxcorp, Johnson, all this thing, but your data still is not normal, so you can go for the non-parametric, but you need to use this kind of the test instead of this one sample t-test, two sample t-test, ANOVA, but you need to use the Kruskal-Wallis and the Moore's median. So I go to the Minitab. I just play around with this part. Okay, so you how to get it? You go for the stat, go for the non-parametric. You will see here is one a sample sign, one sample will cause Mann-Whitney, Kruskal-Wallis, and so on. So in other way that if let's say your data set is not normal, so no worry, you still can do the data analysis, but different way is we call the non-parametric. Okay, so we use the Mann-Whitney, Kruskal-Wallis, and so on. Maybe after this webinar, you can go for Google to what is the Mann-Whitney or something like that. Or maybe you can go for this tag and then you just go for the hub mini tag. We give you the information. So when to use the Mann-Whitney. Okay, so for this case, I try put this part. Okay, try put this part. So this one. So what is this? What is main menu? How to do? So you just go back to this part. Okay, you open your one of this dialog box. You go for the hub. Okay, as long as you have a internet connection in your laptop or PC, so we go for this hub. Okay, so then we go for this hub. So we get this part. Okay, how to, and then go for the overview. So when to use this. Okay, so main menu actually do determine whether the population median of the two group are differ, or maybe you want to see the calculate range of value is likely to include the differences. So when use the alternative analysis. So that one is it's not so cute. So you will use the two sample t-test. So everything you just go for this part and then you find where go for the stack, go for the non-parametric. Maybe you want to see the Friedman. Okay, where is the Friedman? Click hub and then mini tab. We go back or give you the information how to do and what is, okay, what is, and then maybe you want to see the practical, okay, so you can go for the example here. So they give the example. You can download this part as long as you have the United Statistical software. You can open this data set. You can follow this step and then you can interpret. They give you the interpretation. And of course, you want to check whether it's a formula, okay, whether it's have a formula on that for this kind of the number. So you go for the method and formulas. So you will see on this part. So give it the formula. So they give it you this notation for the each formula here. So that one maybe is easy for you to get more information on this part. Okay. So for the first step, you go for the non-mathematic, or maybe you want to use the individual distribution identification. So this one is the in Minitab for information. We have 4514 distribution, provide the best fit for your data. So the strategy in order to choose a distribution, maybe the first one, it will be the most commonly used, okay, in your industry or application. So maybe you need look back to the historical data set, or you look back into your subject matter expert on that part. So before you choose the distribution, and then of course after you use that, you go for the second one, maybe that provide the most conservative result. So maybe it will be more reflect to your result. Okay, it will similar what you want. Okay, and of course we want to you have the simplest distribution that fit your data well. Okay, so for this case we have 1 4 type of distribution, but if let's say not fit with the 40 type distribution, maybe you go back to the non-parametric. Or maybe for this case, maybe for those are using for the CPCPK, or maybe for the reliability engineering, you must have a fit distribution. So you must use this individual distribution identification. Okay. And then here I have one case study here. So the quality engineer for the nutrition supplement wants to assess the calcium content in the vitamin capsule. The engineer collect the random sample capsule and record their calcium content to determine the way statistical analysis is appropriate for the data. For the data, the engineer first needs to determine the data distribution. Maybe this engineer want to see the capability analysis, is it capable or not capable. So you must know about the distribution identification. So this one also we have So I go to the mini tab, open the current calcium content data set. Okay, so they take it, the engineer take it, measure the calcium content for each vitamin capsule here. So then randomly, so you go to the stat, how to get it, the individual, go for the quality tools, you see individual distribution identification. Okay, so for, of course, for this cat, we have a calcium. So every time they take it only one, so one. But for those for example, you have the subgroup size, so you can type on this subgroup size, and then you will use the specified your no distribution. Okay, so we have a 40, include the Boxcott and the Johnson transform. Okay, so for this case, or maybe you will use all distribution and transformation. Just click OK. So you will get this part. Okay, so I will go to stat, go to quality tools. You see the individual distribution identification. So you put the calcium here, your subgroup size, and then use all this distribution, and then you click OK. You will get this result. Okay, so we give the 2 parameter exponential, and then 3, and then of course still provide you the PPP plot. Just now we do this part, and then we do all this 40, and then of course we need go for the goodness of fit test. Okay, so we have a ID, and then star still, and then the p value and RTP p value. So for the RTP value actually is have a 3 parameter. For those distribution have a 3 parameter, they're not able to calculate the p value, but they provide you the LRTP here. So the same is a highest value of this, it will be the fit of the distribution. So for this part, the 3 parameter will work with both the highest value of the P, the more significant or more fit to this calcium content. Okay, so you'll be on this part, or maybe you need to go for the graphical side here. So we see the 3 parameter will book. Which one is the? This one is a part. So you will see a line inside this confident interval, and then inside based on this straight line, okay, can form the straight line. So we consider that the calcium distribute by the 3 parameter will. But of course, you want to see the larger, back to the stat, go to quality tools, individual distribution. You can go for the specified. Just only go for the 3. Click OK. So we get on this part. The skewness, the fitness, okay, and then the ML distribution parameter here. So now you see for the 3 parameter here, they not look the mean, they not look the standard deviation, but they look the location, the shape, the scale, and the threshold. So for the 3 for the whale they look on the shape, scale, and the threshold. But for the normal, you will look on the mean, we look at on the standard deviation. Okay, of course this part it will different type of the distribution have different type of the parameter here. Okay, so go back to this part. Okay, so the last part is go for the transform non-normal data set. So sometimes we can transform your data by applying the function to make your data fit a normal distribution. So you can apply this transformation directly into your data worksheet, or you can use the Minitab calculator, something like you want to log, you want to inverse something, the simple one, so you can use the Minitab calculator, or maybe you can go to perform a Boxcott transformation. Okay, so Boxcott is simple rather than Johnson transformation, but of course it's simple, maybe it was limited and often does not determine the suitable transformation. And the Johnson is function more complicated, it's not so straight way, okay, but it will be very powerful for determining an appropriate transformation. So how to get this part, I try with this one case study here. The textile manufacturer developed a solar energy system to preheat the feed water for a boiler that is a part of the power system for the manufacturing process. Okay, so the technician that after confirming that the data is stable and does not include any outliers, the technician conduct a normality test and find that the data does not follow a normal distribution. So the technician then conduct a box plot analysis to determine whether it's a box plot transformation is appropriate before creating a IMR check of the data set. So in order to check is normal or not normal, they need to have the data is stable, and then there is not include any outliers to or to after the checking is not normal. So they want to see by using the box score, it will be the normal or not normal. So for this case, we try with those kind of the box score transformation. So I go back to the mini tab. Okay. So I use the solar energy power here. So every time, every hour, they take it the energy here. So how to get it, the box plot. So you go to the stat, go to the control chart, you will see the box plot transformation. Okay, so of course this part is the energy. So our subgroup is a 1 or hours, you can type it here. So maybe you go for the option. So you want to round out, or maybe you have between them. Okay, so you store in your one store, maybe C4, C3. Okay, and they click OK, and then you click OK. So you will see at the same time, you will store your transformation. Okay, and then of course you will get this part. Okay, so for this part, I have this how to interpret or how to this one. Okay, so use the confidence interval to determine whether its transformation is appropriate as follow here. So this one is a lambda value, okay, of lambda value you will see the here, okay, is equivalent to using the original data set. Therefore, if the confidence interval for the optimal lambda include 1, okay, between this part have a 1, they no transformation is unnecessary. Okay, for this lower confidence interval, lower and upper this one. If the confidence interval for does not appropriate include 1, transformation is appropriate. So for this our data set, the 95% confidence interval for lambda is between negative 2.49 to 0.84, does not include 1. So a transformation is appropriate. So mean to say that you will see on this part, okay, you will see on this part, this value. So once the one is a good, okay. So after this, you want to continue your data analysis, you use this part, okay, this value instead of this value. Okay, you use the transform value instead of this value. Okay, because you want to see on the normality. So say this is a normal, so you go for this value. Okay, so that's why not all the researcher outside there we use the like it use the transform method because they not use the original value. They will use the value of the transformation. Okay, so we go for the next part is the Johnson transformation. Okay, so in the Johnson transformation, the objective will be the same. You just only different function to transform your data set. Okay, so how to get it, the Johnson transformation? So we go back to the mini tab. Okay, use the same case study here. Okay, so the hour, every hour they take it the energy, solar energy here. So go to stat, go to the quality tools, you will see Johnson transformation. Okay, so the one is the same. Okay, maybe it's store on the C4. Okay, so you want to store the C4 value. Then click OK. So we get the Johnson transformation for energy. So in the Johnson, okay, give you the p value, the best this one, and then that one is the function, how they get it this value. This one is a function, the equation to get this value. So we do go to stat, go to the quality tools, go to the Johnson transformation. So you choose the energy here, Then you click OK. So you will get this part of the Johnsons. So that one, the Johnson, they will give you the original one. They give you the transform data set. So once they use this, okay, for the PP plot here, they will use this part, this value, okay. So they use this value to create the PP plot, and then you will use the P value is more than 0.05. So we consider that the transform value now is normal distribute based on this P value. Okay, so how to get it this value? Based on this equation or formula to get it this value. Okay, back to this part. I think then. So in order to best part handling the non-normal distribution based on your sample size first. Okay, if let's say your sample size is quite small, you need to add more sample size. Okay, but let's say you already add the sample size, but the normality is not stay normal, maybe you need to look on the outliers. Okay, so if let's say not no outliers, but it's still non-normal, so maybe you have this option, whether it's using the non-parametric, okay, or we using on the distribution fit to one of the distribution, and of course maybe you will use the transformation. So with what transformation? Maybe we go for the simple one first before you go for the complicated one. So you need to try and error for this part to handle it for the non-normal data set. But all these thing is based on your afterward what you want to do. For example, for the reliability engineering, so you need to have the distribution part. So maybe you need to have the distribution must be fit before you go further for reliability engineering. But for those are looking for something post testing, okay, so you have an alternative way, okay, so you can use the non-parametric. But for those are something like want to see non-normal, okay, but it is a simple one also, or standardized, or this transformation, okay, so they will be the normal, so you can proceed with the transformation. But just on this transformation, you are not using the original value. You're using the transformation value to proceed to others statistical tools. Okay. So if you have a question, so type into the chat box. Okay, we have one uh, question here. How sample to be considered sample size? How small sample to be considered small sample? Okay, so uh, that one is a tricky part question. Okay, it will depends on your population. Okay, so if let's say your population only 10, so you have the 5 sample from your population, we consider 50% out of your population. Okay, so it will be depends on your population. So you must back to the basic one. What is your population before you take it? Sample, is it a bigger sample or lower sample? But if let's say you have 1 million population, so if let's say you take it only 5, it will be goes to smaller sample size. So, I think we have a lot of question here. Okay, just put the sharing good. Okay. Okay, the one is I have a question here. When we are assessing the normality, it is compulsory to have the data set with the same sample size. Okay, the same. You need to go back to your population. So what is your population? How many data in your population? Okay. In order to get the data collection, also we have a type to sampling method. So we have the snowball sampling method, stratified sampling method, randomized centimeter. But in the manufacturing, basically we say that randomized. But based on what you randomize, is it time? Is it a batch? Is it of your machine? Is it of your operator? It will depends. Okay. Will it answer your question? Okay. So that's why you need to know about uh, how you collect your data set. For those are related with the service industry, okay, you using the Likert scale 1, 2, 3, 4. I think it's harder to get the normality for that kind of the feeling. Okay, it's something uh, you cannot measure directly. Okay, you can okay, in the manufacturing you will have a caliper, so you measure directly, you will get the measurement. But for the industry, okay, so you need have something like based on your standard. Okay, for example, the waiting time. So your patient coming to your fee, your registration part or something, that one is a waiting time. Waiting time cannot be something symmetrically. Maybe we start with the something skewed. Okay, so the original one is skewed. So it's a difficult to transform to be the normality. So maybe you can proceed with the fit into distribution. Of course, when you fit the distribution with the for example Weibo, so you can consider that one is a continuous. Okay, must a continuous measurement. Let's say you can proceed with the regression, you proceed with the something like CPK, okay, or so on. So as long as a number continuous, you can convert it, so you can assess the normality. But if let's say your it's not cannot convert into continuous, okay, maybe you can uh, proceed with the attribute data set. So we have a others something like we have chi-squared to see on the something like one sample t-test, something like one. Okay, so we have an alternative way to solve that kind of the data set. Okay, so we have a lot of question. Okay, for those I want to this material, so you can drop your email into the chat box. I will send after this. So after this, no need to worry if let's say you have your normality, non-normal distribution. So you can proceed with the data analysis, but you need to have something non-transform. Maybe you using the non-parametric, or maybe you using the fit distribution onto that. Okay. We this one. Once you already transform your data set, so you need to use the value for transformation data set. So that's why not all the researcher using the transform because not use the original data set. Okay, so we have the others question. Is okay to change the sigma to 3 sigma? Is allowed? I'm not sure. Is it referring to what? Okay, maybe you can email to me to in order give me more understanding on this part. Okay. Okay, so the next part. Okay, so for those I want to see more the application of this all these thing. Okay, we have the spatial webinar for the next month for the streamline automation and analysis with the Minitab integrated SPC. So for those are looking for integration between to see Minitab statistical software also can integrate to others application. So I think you can scan here to register, or I wait give me time to get it link to paste it into the chat. That one is live on the for April. Okay. So for those are looking for the some uh, integration to see the Minitab also integrate with the others application applicable to uh, integrate with the other application also. Okay, so thank you for your time attention. So to learn more about the Minitab, we highly recommend you join our training. So if interest on the training on our product Minitab, please contact us by visit our www.minitab.com or www.visit.com or email to us minitab@visit.com. So to get some tip and trick on our Minitab product, please follow us through media social like Facebook and link at the Minitab Malaysia and Singapore. To access back our previous webinar, please subscribe to our YouTube channel, Minitab Malaysia and Singapore. So really appreciate if you fill out our survey in order to enhance our webinar session. So happy learning. Thank you.